Okay, so am I audible to you? Just check it out whether you can hear me. Just check once whether you can hear me. Okay, great. So if you can hear me, let's start pulling this lecture. Now, this particular video is this particular live session is about some topic of production engineering. So, production engineering may there are a couple of topics which we can cover, and the target questions for two exams, that is BHEL and HPCL, the exams which are coming. We will pull some live sessions on production engineering. Many students were saying that production engineering is a topic they still need to revise. You can take these notes, you can take these PDFs available which are being prepared for the questions. I will add some really good question in this which are expected in BHEL and HPCL exams, and many questions are previous year's questions. So let's start pulling this particular lecture now, and I'll be explaining today in this particular lecture. I'll be going for casting process. So production engineering, as you know, is a very vast subject. So I'll be picking some topics of production engineering, and we'll be going for that, right? Uh, okay, let's see. So we proceed ahead with that. So let's proceed with the questions first. You keep reading the questions and let's try to answer the questions. So let's make it a more interactive class. So आप class में you keep on answering the questions and then we proceed. First question is related to chaplet, which is used in foundry practice. So what is the main purpose of chaplet? That is a question. What do you think is the main purpose of chaplet? Yes, the main purpose of chaplet is to support the core. So chaplet is used to it's a small metallic piece which is provided to give the support to the core from shifting its position. That is the extra support given to core. Abhi, you see this diagram carefully. In this diagram you will find that there is a core. Why core is created? Core is created to provide some kind of hollow section. So you know the logic of core. Core is given some kind of support which is called core print. So you should know a couple of things here. This is the core which you have, and this particular part is called core print. The support which is given to the core in the cope and drag, that is called core print, and the support, metallic support, which is given to the core to prevent the force of buoyancy. So what force acts on the core? The force which acts on the core is called buoyancy force, and to prevent that buoyancy force from shifting that core, we provide the chaplet. Chaplets are nothing but they are the metallic location pieces. Location means they will make the core particular fix at one particular point and do not let the core shifting its position. So why the core will shift its position? Because of buoyancy force. So they are the metallic pieces. They keep the core at their location. The force acting on the core is buoyancy force. Core is basically there to produce the hollow sections, and core is also given the support in the cope and drag part through core print. These three things you should know. So maybe from the other visual you can find out the kind of chaplet which we are providing. Normally chaplet is of the same material which is that of the cast metal. So it is the same material which is used. चैपलेट का एक और नाम होता है जिसको बोलते हैं स्पेसर. सो प्लीज राइट दिस नेम आल्सो इन योर कॉपी. Sometime he will ask you what is the meaning of spacer, what do you mean by spacer. So chaplet से related दो तीन चीज तुम लोगों ने पढ़ा है. What is the important thing? One is buoyancy force, another is spacer, then it is the metallic location piece, and then it gives the support to the core. That is what the chaplet is all about. And which part you provide the chaplet in cope or drag? As you know, cope upper वाले part को बोलते हैं, drag lower वाले part को बोलते हैं. So in which part do you keep the chaplet? Answer is in both the parts we keep the chaplet. Whether it is cope or it is drag, we provide the chaplet in both the parts. So this is very, very important. Spacer is the name of chaplet, and chaplet and chill, these are the two things which we should study in the casting process, and that is the meaning of it. Now I go forward and let's see this particular diagram again. टाइप्स होते हैं कोर्स की, कुछ टाइप्स हैं. वर्टिकल कोर होता है एंड देयर इज अ हॉरिजॉन्टल कोर. Sometime question can be asked which of the following is not the type of core, which of the following is not the type of core. So horizontal core is there, vertical core is there, balance core is there, hanging core is there. You can see this hanging core, and hanging core में these particular things which are holding the core are also chaplet. So hanging core को आपको पकड़ के रखना है. So that hanging core which is provided in the molten metal, the hanging part is basically also the chaplet. उसको हैंग करने के लिए रखा होता है जब आपको बिल्कुल बीच में hollow section is required. And then there's a drop core, and then there's a kiss core. I don't know why this name, but this is a kiss core. This is how it is: drop core, hanging core, kiss core, vertical, horizontal, balance core. These are the types of the cores which you should know. एंड कोर प्रिंट मैंने आपको बताया, स्प्लिट पैटर्न में कोर प्रिंट होता है जो स्कोप और ड्रैग पार्ट में उसको सपोर्ट करने के लिए होता है. एंड चैपलेट इज नथिंग बट दिस इज, एज आई टोल्ड यू, चैपलेट उसको सपोर्ट देता है. सो दिस इज व्हाट कपल ऑफ थिंग्स यू शुड रिमेंबर अबाउट कोर. सो व्हाट इज द हैंगिंग कोर, एंड हैंगिंग कोर में जो सपोर्ट देता है दैट इज द चैपलेट पार्ट. एनीवे, लेट्स गो टू द नेक्स्ट क्वेश्चन नाउ. कोर प्रिंट आर यूज्ड टू, बताइए जरा, इसका आंसर लगाइए जल्दी से. And in the form of answer, I'll provide you some more information also. So core print is used to, what for do you use the core print? Yes, go ahead and tell me why do you use core print. Okay, form seat to support and hold the core in the place. That is very nice. That is the answer for this. So this is provided basically to give the support to the core itself. डिजाइन इज पार्ट ऑफ योर एंटायर गेटिंग. डिजाइन का पार्ट होता है कोर प्रिंट प्रोवाइड करना, सो दैट कोर कुड बी सुटेबली लोकेटेड हियर. कोर प्रिंट आई ऑलरेडी एक्सप्लेन्ड यू. सो इट प्रिवेंट्स द सैगिंग एंड रेजिस्ट द हाइड्रोस्टैटिक मोल्टन metal pressure. So I told you there are two kind of forces which are acting on the core: hydrostatic pressure force and buoyancy. Do you think these are same or different? Is the buoyancy force similar to hydrostatic pressure force or different? And fluid mechanics mein you study that buoyancy force and hydrostatic pressure force are the same thing. Let's say the pressure acting from the top is P1 and the pressure hydrostatic pressure force acting from the bottom is P2, and on the side also the hydrostatic pressure force is acting. So what is the net pressure force acting on the body in the fluid? So answer is, sir, net pressure force is P2A minus P1A, because side wala pressure force will be balancing. So net pressure force acting on the body is nothing but P2A minus P1A. And what is P1 P2? Rho GZ. So when you multiply this P2 minus P1 जब आप करेंगे तो आ जाएगा rho into G into this particular entire thing. Let us say this is L. Rho into G into L into A. That is nothing but buoyancy force. So exam में he might ask you, कोर के ऊपर कौन से वाली फोर्स लगती है, buoyancy force या hydrostatic pressure force, कौन सी लगती है? So basically buoyancy force, as you rightly said, is the effect of hydrostatic pressure force. So maybe this particular diagram is visible to you. So core print is nothing but scope और drag के बीच का जो portion है, that is the core print, and that is provided to keep that particular body, keep that particular entire casting in the proper position. Okay, go for the next question now. Due to shake allowance, answer the question. Due to shake allowance, fillets are provided on the pattern. Pattern is made slightly bigger. Taper is provided on the vertical faces. Pattern is made slightly smaller. So tell me, शेक अलाउंस से तुम्हें क्या करना पड़ता है? पैटर्न को बड़ा बनाना पड़ता है या छोटा बनाना पड़ता है? So pattern is made slightly bigger than required size. Okay, pattern is made bigger or pattern is made smaller. What is the answer for that? Okay, some of you are saying smaller, some of you are saying bigger. So due to shake allowance, the pattern is made slightly smaller than required size. Because before the withdrawal from sand mold, the pattern is wrapped all around the vertical faces to enlarge the mold cavity slightly, which is helping its removal. So because the casting size is going to get larger, इसलिए pattern should be made of small size. So we know there are different kind of pattern allowances. We know these kind of pattern allowances. These are shrinkage allowance. So liquid to liquid, liquid to solid shrinkage allowance is there. And then there's a solid to solid shrinkage allowance. and then the machining allowance, then there's a draft or taper allowance. इसका याद रखना, taper basically draft allowance is very very important जो हमें करना होता है. Then chamber or distortion allowance, and then shake or wrapping allowance. So these names also remember. Normally students do not remember these names for shake allowance and draft allowance. ये नाम भी याद कर लो. Please remember these names also. They are also important. So what is the other name of draft allowance and what is the name of shake allowance? And this question is related to shake allowance, which we call wrapping allowance also. Shake allowance is also called wrapping allowance. So you should keep this thing also in mind, which this particular allowance is called, shake or wrapping allowance. Now these are the different kind of allowances which are to be provided, and this is how it is done. So this different color is telling you what should be the size of the pattern, what should be the size of actual casting, and what is the size of the molten metal when it is poured. So wrapping allowance में हम क्या करते हैं, हम see distortion allowance is also there. So what should be the required size? What we finally want is a red color. What we finally want is a red color. So if we want final red color, then actual required size is this, but the actual size of the pattern is something which is to be made big. So black size is pattern size. So if pattern is large and shrinkage is there, so actual size will be less. Similarly, if the pattern is of this shape and then distortion takes place, तो red color में तुम्हारा distortion के बाद actual shape comes. That is how basically you are going to get it. Effective sizes after machining and all, you tend to get this particular thing. So the same thing, we discussed about how distortion and camber is provided. These allowances are taking care of this distorted casting. So if you want this kind of casting, you need to make this kind of pattern first, and then after this, the moment you do casting, you get this final shape. So you need to give that kind of cambering is provided on your this pattern. Okay, let's go for next question. Property of molding sand which does not provide any resistance to contraction of the solidified casting is called what? So just give the answer to this question. What is the answer to this question? What is the property of the molding sand which does not provide any resistance to contraction of the solidified casting? What is the answer to that? Okay, that is permeability. No, permeability is not the answer. So what is that property of molding sand which actually does not provide any resistance to contraction of solidified casting? So if solidified casting wants to contract, it does not provide any kind of resistance. So what is that property called? So give the answer to that property. What is the answer to that property? Collapsibility. Okay, so these are the properties of sand. So collapsibility is the answer. Collapsibility is that property of the sand which does not provide any resistance if the casting wants to get solidified. Adhesiveness is different, and refractoriness is the property of sand to withstand high temperature. That is another thing. Collapsibility is that ability of sand mixture which collapse under force. So greater the mold collapsibility allows molten metal casting to shrink freely as it solidifies without the risk of hot tearing or cracking. So if collapsibility is not good, what casting defects will be there? So hot tears and cracks are typically defects related to poor collapsibility of the sand. So if the collapsibility of the sand is not good, then hot tear, as you know, hot tear is one of the very, very important casting defect which you should know. And casting may say casting defect question can be asked to you. So if this this collapsibility is not good, collapsibility of the sand is not good, typical the problem which comes is the hot tear. So hot tear in cracking is the typical defect of casting if collapsibility is not good. That is the meaning of it. So there are certain defects of casting which are related to poor these properties of the sand mold. So sand ki there are some properties. Permeability is also one of the property, we will discuss that also. Refractoriness is also property. Collapsibility is also one of the properties of the sand. Okay, next question is related to chills. So tell me, what is the chill? So give A, B, C, D. What do you understand is the meaning of chill? What do you understand by chill? Okay, chills are what? Mixed in sand to enhance its collapsibility, or metallic objects to provide very high heat extraction, capability of sand mold to provide strength to sand mold, low heat extraction capability. Yeah, so they have high heat extraction or low heat extraction. What are chills? And let me tell you, chills are metallic objects. Like chaplet, chills are also metallic objects. So what do they have? They have high heat extraction capability or low heat extraction capability. So they have very high heat extraction capability for sand mold, and they cool at certain rate, which is related to the thickness of the casting also. It leads to directional solidification in specific portion of the casting mold. So metal in mold cools at particular rate depending on the thickness of the casting. So chills actually lead to the directional solidification. There are two kind of chills. One are internal chills and other are external chills. One are inside the molten metal and they basically melt. So the two categories of the chills are internal and external. They lead to the directional solidification, increase the solidification rate. They are the metal, I mean the metal of molten metal, this metal and this same metal. So chill are made up of the same metal as what we are going to cast. So molten metal which we are going to cast, chill are also made up of the same material, and these chills provide the directional solidification. So solidification will start where the chills are kept. Grain refinement or solidification will start from where we keep the chills. If we kept the chill at particular point, so solidification will start from there, and that will prevent the casting defect. So what defects chill will prevent? Which casting defect chill will prevent? Answer me that question. So if chill is kept at some particular place, which casting defect it prevents? So internal void or porosity inside. Porosity, as you know, is a casting defect. So porosity is one type of a casting defect. So if chill is not provided, which of the following casting defect can be there? Hot tears, rat tail, or some kind of swab, or porosity. So you should know, if you do not provide the chill, what casting defect can appear. So as I told you, that can be porosity. Internal void or porosity inside the casting can be there because of this. So they have very high heat extraction capability. They are made up of metal and they have very high heat extraction capability. Yes, voids or porosity are the casting defects. So remember these two important informations related to chills. Okay, shrinkage allowance. Answer the question now. Shrinkage allowance on pattern is provided to take care of what? Shrinkage allowance. Shrinkage allowance on pattern is provided to take care of what? Liquid shrinkage, solid shrinkage, liquid and solid shrinkage, what? So answer this question. Shrinkage allowance on pattern is provided to take care of what? Okay, let me answer. So you mean to say liquid and shrinkage or both? Answer is both. So both liquid as well as solid shrinkage pattern will be taken care of. Solid shrinkage and liquid shrinkage, it takes care of both liquid and solid shrinkage. What happens is, first there is a liquid state. So liquid means there is a temperature change in the liquid from pouring to room temperature. When the liquid changes from pouring to room temperature, then there will be some kind of shrinkage. And when it changes the phase, again there will be some kind of shrinkage, right? So solid and liquid both you are talking about in that particular case. But there are risers also. In the risers may you basically riser also is linked to this kind of shrinkage later on, that molten metal is provided when there is some kind of molten state may shrinkage is there, that can be taken care of when riser is provided. So that I will discuss with you next in the next question. So this is the kind of shrinkage allowance which is provided. So there is a pouring temperature. From the pouring temperature to room temperature, there is some kind of shrinkage. Then there is a phase change. So liquid state to solid state, and the solid state also. This is basically the temperature at which the solidification takes place. So from the solidification to room temperature also there is a solid shrinkage. So there's a liquid shrinkage, and then there's a solidification freezing situation, and then there's a solid shrinkage. So this is how total solidification is there. So what is solid shrinkage, what is a liquid shrinkage, is very clearly visible here. You can understand the solid shrinkage and liquid shrinkage. So this is what is provided by the pattern allowance, right? Freezing temperature, room temperature, pouring temperature. So this is the pouring temperature, this is the freezing temperature, this is the room temperature. So three temperatures are taken care of, three temperatures we are talking about here. Okay, so let's go for next now. Next question is related to when we decrease the clay content in molding sand, what does increase? As I decrease the clay content, which property of the sand will increase? With the decreasing clay content, which property of the sand will increase? Refractoriness, permeability, green strength, or flowability? If I decrease the clay content, what will increase? Yes. So you are saying permeability will increase. You are right. Permeability is something, as you add the clay content, so permeability, as you decrease clay, permeability increase. Permeability is nothing but this is the space between the grains for air to move, right? The space between, as you keep on adding the clay, space will keep on getting reduced, and permeability will decrease. So clay content and permeability are oppositely related. So more the clay content, less is permeability. And what is permeability? Basically space for air or space for gases to escape through the sand. That is how it is. So typically this the material which are there in green sand, that is a silica is there, bentonite is there, coal dust is there, water component is also there. So percentage also so clay reduces the conductivity also of the sand. So these clay has two impact, one is on the conductivity of the sand and another is on the permeability. So at particular percentage, permeability will be very less. So remember, these two are affected by the clay. Refractiveness of molding sand can be increased by what? How shall you increase the refractiveness of the molding sand? So just give your answer to this. Refractoriness of molding sand can be increased by what? What is your answer to this? Increasing the grain size, decreasing grain size, increasing the water content, increasing the clay content. How do you think refractiveness is related to the grain size? Whenever you get these two, increasing or decreasing, there's a very high probability that A or B will be answer, because either it will increase or it will decrease. So one of the answers will be there. So what do you think is the answer? How the refractiveness of the molding sand is related to grain size? Okay, answer is A. So refractiveness is the ability, what refractoriness we know is withstand high temperature when molten metal is poured into it and not get fused with the metal. So now silica sand has very good refractiveness, and it is measured by center point of the sand. This is very, very important. So note this particular thing also. How do you measure refractiveness? Center point of the sand. And it is increased by increasing the grain size. As you increase the grain size, refractiveness also increases. Center point or sand, center point or melting point. So center point measures the refractiveness. So remember this center point, and it depends upon the kind of sand you have. So silica SiO2, shape of this, and grain size. So this is the parameters which decide the refractiveness. So as you keep on increasing the sand content in your mold sand, SiO2, as you keep on increasing silica, refractoriness increases. As you keep on increasing the grain size of this sand, that refractoriness keeps on increasing. And size increases and quantity increases of the sand, it will keep on increasing the refractiveness. So remember these two things. This is very, very important. How this refractiveness is related to the size of the grain. Okay, so I think this we have already answered, but this is a different question. So what is the answer? Very quickly you can answer this. What are the advantage of the chills? What is the other advantage of the chill? Chill are used in casting to do what? So answer this question fast. Why chill is used in this? Improve the directional solidification. So what is directional solidification? So very high thermal conductivity is there and high melting point temperature. Uniform cooling rate is to be obtained. So what you want is cooling rate you want is uniform. So what is the advantage of this is I want to get uniform cooling rate and minimum cross section in mold cavity to maximize the heat transfer. So where is it provided? Where the cross section in the mold cavity is minimum. You provide the chill where cross section is minimum, there you put the chill so that the heat transfer rate and direction solidification can be properly used. So where do you provide the chill? We provide the chill where the cross section of mold cavity is minimum. At that point we provide the chill. So that is something which is important. You should know that directional solidification is achieved using Cherepanov rule to design the casting itself. So how do you achieve? There are three ways to achieve directional solidification. Remember, these are the three ways in which you can achieve the directional solidification. One is Cherepanov rule. Cherepanov rule. This is a tongue twisting word. Okay, so Cherepanov rule is one of the rule. I'll discuss with you the formula of this. That is one of the way in which directional solidification is obtained. तो आपने casting का, the design of the casting itself will provide the directional solidification. I'll tell you how it is to be done. And riser system, how do we design the entire gating system? Second is you will locate the section of the casting with lower volume to area ratio away from riser. So freezing occurs first in these regions and the directional solidification is provided. So V volume to area ratio during design itself will decide the directional solidification. And the third way is that there is a chill which you can provide. So there are three ways in which directional solidification can be obtained in the casting. What are the three ways in which directional solidification are obtained? One is riser system, another is V over A ratio, third is the chill. There are three ways in which directional solidification can be obtained. You can get the directional solidification using these three ways. So remember, this is very, very important, and the three ways you can obtain it. Okay, which of the following generally has square cross section? Just hit the answer. So ingot, bloom, slab, billet, which has square cross section? Tell me which one is having square cross section. So these are the expected some questions of these exams, some of the questions which have already been asked in the previous years. So which of the following has square cross section? Tell me which of the following has square cross section. Yes, answer from your side. So A, B, C, D. Okay, so answer for this is billet. Billets have square cross section. See, bloom is a large size, and from bloom itself you can get the billet. Bloom can also have square cross section, but it may not be square also. It can be rectangular. But billet has a small size it is, and billet has a square section. So there is a difference between ingot, bloom, slab, billet. All these are different. So ingot is a brick of cast iron, basically directly obtained from foundry. So from ingot then you get bloom. Bloom is intermediate product. It can be rectangular, it can be square cross section. Then slab is again this is a sort of plate, and billet is square cross section which you get it. So billet actually has square cross section. अभी इनका अलग से diagram देखते हैं. This is how you get it. So billet is having a section which is a cross section is a square, and from billet further, as I told you, ingot से तुम्हें दो चीज मिलेगा. You get two things from ingot. Either you get bloom or you get slab. Slab से further you get the sheets, and bloom से you get either billet or you get the bar. So this billet itself is a square cross section, and billet itself will provide you bar or it will give you rod. So from the billet you get either bars or you get the rods. that is the product. Bloom say you get the structural shapes further, and as I told you, bloom can be rectangular section, it can be square section, and from slab you get plate, sheet, coil. So these diagrams are very important diagrams from where you can make up your mental map about these shapes. So this can be rectangular, but this is the square. So billet is always square, and ingot, and then comes bloom, then comes billet, and then comes your bar. So size wise, ingot is the maximum size, then comes bloom, then comes billet, then comes bar, and which has square cross section. So billet has square cross section and bloom has rectangular cross section. So just see these diagrams, they are very relevant diagrams for exam. You can think of what answer you can further basically give for it. So coils are very thin sheets, that is called coil. So coil is the very less size thickness these sheets, right? So make up your mental map of this ingot. Then ingot say you can get either slab or bloom. From bloom you can get billet or bar. This is how it is related. Done? Yeah. So let's go for next. Bell shape are generally made by which kind of pattern? Which pattern is used to make the bell shape? Tell me which pattern can be used to make the bell shape. Give the answer to this. Generally most of the questions which you come across in these exams are simple. I mean, for BHEL or HPCL, the questions will be very simple. The difference, there are only some questions which can create the difference, and if you make that wrong, you may not get the call of interview. If you correct it, then you get the interview call. So bell shape is by the sweep pattern. What is sweep pattern? As you can see in the diagram, so there's a pattern made up of wood or something. You attach it on a stick, wood, and then you rotate it. The moment you rotate it, you can get the bell shape, right? Three-dimensional bell shape you can get. So three-dimensional conical or bell shape can be obtained by sweeping pattern. So large symmetrical casting. So why sweep pattern is used? Large size के लिए होता है, and that is for symmetrical casting. And it is made up of wood, basically board, and it sweeps around the circumference. Lot of time and labor is saved. Large circular sections can be made of symmetrical shape, and you use it to make wheel, rim, bell shapes. Those kind of things can be made. So sweep pattern, and then that means patterns are also important. So you should also know about the pattern. So sweep pattern are made up of this wooden blocks, wooden basically boards. The sweep pattern can be made. Okay, let's go forward. Which property of molding sand allows gases to escape from the mold? Everyone can answer this. Very simple. This is a very simple question, but the kind of questions which you may get in your exam. So molding sand that allows the gas to be escaped from the mold. What do you think is the answer for that? Yes, that is the permeability. So what is permeability? What is refractiveness? What is flowability? Those things are very important. So property of the molding sand that allows the gas to escape from the mold is called permeability. Withstanding high temperature is refractoriness, right? So venting behavior, you know what is vent? Vent is escaping of the gases is called vent. So vent behavior, how well the gas can go from the sand, that venting behavior is related to permeability, right? Permeability is the property, ability of the material to transmit the gases or fluids. That is the meaning of it. Okay, which of the following processes is suitable for making hollow parts with the thin sections? Okay, hollow parts with thin sections. Any idea? Which process will you use to make hollow parts with thin sections. What is the answer? Okay, so you mean injection molding? Okay, what do you understand by blow molding? What do you mean by blow molding? This is basically hollow plastic parts of very thin sections are made by blow molding. You know this there is a plastic which you melt, and then blow molding process is used. So plastic bottles which you see, like this kind of bottle, are actually made from, you know, this kind of material. So this kind of bottles which you see are made from blow molding process. So compressed air is passed. Let me explain this particular process to you. Maybe this is visible to you. See this process. This is the blow molding process. Melting of the plastic is done, and then melted plastic is passed over a tube which is basically a void, and then it is closed, and you know, mold is made, something like that. So compressed air is made to flow. This is a plastic, and this is the kind of pattern. So plastic, and then air is blown inside that compressed air inside the plastic, and like, you know, balloon, you know, the balloon, when you basically want to inflate it, so you pass the compressed air through it, and then it will blow to one particular shape, and that shape is the final plastic bottle shape. So thin size, and this is how you get it, and it is hollow from inside. So this is the blow molding process. So plastic bottles are made through blow molding processes. Taper. So which allowance is related to tapering? Which allowance is related to tapering process? So which allowance leads to the tapering? Taper is provided by which allowance on the pattern for its easy and clean withdrawal? So the pattern taper which is related to the process which is called clean withdrawal from the mold. Okay, so that is a draft allowance. Now draft allowance is provided like this. If draft allowance is not provided, the moment you withdraw it, there will be damaging, you know, the mold cavity will be damaged. So for easy withdrawal, you go for, you know, draft allowance is provided. It is provided on all the vertical walls of the pattern for easy and clean withdrawal of the pattern from sand without damaging the cavity. And see the unit which is there. So what is the unit of draft allowance? Sometimes this question is also asked. Millimeter per meter on the side or in degree. So millimeter per meter can also be unit, or it can be in the degrees also. So amount of taper varies with the type of patterns. So it can be millimeter per meter, or it can be in the degrees. So wooden pattern require more taper than metal pattern. Now this information, you see, this is also important information. As far as the pattern is taper is concerned, so wooden pattern require more taper than metal pattern because of greater frictional resistance of wooden surfaces. So see, this is a very, very important information for you. Please note this information. So if the pattern is made up of wooden, then you need to have more taper on it because greater frictional resistance is there on the wooden surface. So when you want to take it out, the kind of taper which is required is more. So wooden pattern require more taper than metal pattern because of greater frictional resistance on wooden surface. This is very, very important information. Note down this information. Directly exam mein questions can be asked from these kind of informations. And yes, it is measured in millimeter per meter. Let's go to next now. Why carbon dioxide molding? Why do you go for carbon dioxide molding? Give the answer. Why carbon dioxide molding? What is the advantage of carbon dioxide molding? Yes. Why do you want to go for carbon dioxide molding? Do you get hardened mold, or gas can be made to escape easily? React with carbon dioxide to form colloidal solution. Carbon percentage can be increased. Why do you go for carbon dioxide molding? Maybe you know what is carbon dioxide molding. I mean, carbon dioxide is to pass through some sand molding, and that is called carbon dioxide molding. But why do you want to go for carbon dioxide molding? Okay, the answer is yes. Carbon dioxide molding gives you hardened mold. So the mold which you get is a hard mold. You know what happens is this: sodium silicate and sand. There's a sodium silicate in the sand. This is called sodium silicate, and when carbon dioxide is made to pass on this, then you get this plus the silica colloidal solution, SiO2. So this silica is something which is very hard. You know, it's a ceramic actually. So sodium silicate is called water glass. So addition of this sodium silicate, and you know, this is the reason sodium silicate carbon dioxide molding it is called. When hardened sand is there, then you get poor collapsibility, right? And it becomes strong. Hardened sand has poor collapsibility, it does not collapse. So we have already seen what is the poor collapsibility. What is the collapsibility? We have already seen. But remember that carbon dioxide requires sodium silicate in the sand. So you need sodium silicate in the sand. Sodium silicate is also called water glass. So 3 to 6% is required. And when there is a reaction, you get you know, this SiO2. So this is the hardened sand is formed by this. Okay, now there's a numerical can also be asked in the exam. Some kind of numerical can be asked in the exam. So there is a casting process. There is a casting given. Dimension is given to you. 60 by 30 by 14 is to be filled by top pouring. Very simple kind of numerical you can expect. You can expect a very simple numerical. So he will give you the size 60 by 30 and then 14, something like that. So casting size is given. Volume you can calculate. Liquid metal height above top surface of mold is 14 centimeter and area of the gate is 6 centimeter square. So how much time will be taken to fill it? Top gate दे रखा है, तो top gate का तुम्हें area of the gate is given. If I get the velocity at the entry of the gate, if I get the velocity of molten metal at the gate, then area into velocity will be volume flow rate. So I know the total volume. Total volume is 60 into 30 into 40. So if I divide that by VGAG, that is volume flow rate, that is millimeter cube or meter cube, centimeter cube per second, I can calculate the time required for this. So what will be the velocity? You know, velocity is root of 2gh. You know that particular thing. If the head is maintained constant, if there's a constant head, then velocity is root of 2gh, Bernoulli equation. You people are already aware about it. So what is the time required to fill the mold? I give you 1 minute. Try to solve this question. See, you guys are to hit the right answer. If you're not hitting the right answer, that means there also you might face the problem, because question can be asked. So simple question, numerical question can be asked related to casting also. So pouring, I mean pouring time, how much will be the pouring time? That question can be asked to total volume divided by volume flow rate at the in gate. So that question can be asked to you. So he has given you 60 into 30 into 40, and he has given you that the liquid metal height above the top surface of mold is 14 centimeter and area of the gate is given 6 centimeter square. So let's see what is the answer for that. So total volume is given, liquid height is 14 centimeter, area is also given. So what is the time required for filling? As I told you, root of 2gh if you calculate, and dimensions you have to take care. You have to take into consideration the centimeter and meter, and the time is I think 25 point something second you guys are going to get it. So just use this particular formula. So this formula is important formula for your this coming exam. So time of filling the mold cavity. See, purpose of these classes which I'm taking in the production, the purpose of these classes is so that you know which are the important topic from where question can be asked, from where he can ask you the question. That is the meaning of these classes. So you should know this is one of the probable topic from where question can be asked. Now try to solve this question. There is a down sprue of 180 millimeter length and diameter is 20 millimeter at its top end. Gating system design. So one question from gating system design can also be asked. So he's given you down sprue of 1 millimeter length and diameter is given 20 millimeter at its top end. Liquid metal in pouring cup is maintained up to height 60 millimeter. Diameter in millimeter of down sprue at its lower end to avoid aspirations. So avoid aspiration means everywhere atmospheric pressure. So everywhere you need to have atmospheric pressure. If the pressure goes down, if the pressure becomes less, then aspiration will start. You know what is aspiration? Aspiration means suction of the atmospheric gases or air. So suction of atmospheric gases or air is called aspiration. Now you need to prevent that aspiration, right? So you know there's a down sprue, something like this. There's a pouring basin. You are already aware there's a pouring basin. Let us say this is the pouring basin, and then this is the sprue. 0.1 in the pouring basin, 0.2 in the sprue, 0.3 in the end of sprue. So see the question. Down sprue of 180 millimeter length. So this particular is 180 millimeter. You know what is sprue? Sprue is pouring basin and then sprue. So the sprue height is given 180 millimeter, right? And has diameter 20 millimeter at its top. So here diameter is given, D2 is given 20 millimeter. And the pouring cup is maintained up to 60 millimeter height. So this particular thing is 60 millimeter. This is 60 millimeter. So sprue is 180 millimeter. This is 60 millimeter, right? And you have to find out diameter at 0.3. Diameter at 0.3. So simple application of Bernoulli equation. Simple Bernoulli equation in the sprue system. That can also be probable question from the metal casting. So the probable question from metal casting can be use the Bernoulli equation between this. Now, because mass, you can use the continuity equation, right? Continuity equation can be used. Rho 1, A1, V1, rho 2, A2, V2, and I'm assuming the density is not changing. So A2, V2 is equal to A3, V3. What is A1, A2, A3? Area. Diameters are given. D2 is given, D3 we want to find out. So A2 is nothing but proportional to D2 square. So area is proportional to diameter square. So equation can be A2 V2 is equal to A3 V3. That can be the equation, right or not? So here I can also write D2 square V2 is equal to D3 square V3. And how do we find V2 and V3? From the Bernoulli equation. If I apply the Bernoulli equation between this section and this section, this section and this section, I can calculate velocity in terms of height. I can calculate velocity in terms of height. So let's see what is the answer for that. So please solve this question and note the answer for this question. So we are given this D2, D3 I explained you, height is 180, this is 60. So if I apply continuity equation, I get A2, V2, A3, V3 as I told you. A2, A3 will further be related to height. So what is the height from here? Let us say this is this height, and what is the height from here? Let us say this is HC. HC is nothing but 60, and total height is 180 plus 60. So this one is 60. So what is this total height? This is 240. And what is this height? This is 60. So HT is 240 and this is 60. So this is 2. So the ratio is 2. From there I can calculate what is the diameter. This is also very, very important topic from where question can be asked in casting. Small, less time, numericals which are going to take less time. So these numericals can be solved something like that. Right? So please note it down. This is a simple question, not a typical ticklish question. Then question can be, I think this question, similar question has already been asked in the GATE exam also. So shrinkage allowance, question related to shrinkage allowance. So cooling, while cooling a cubical casting of side this, there are allowances which are volume allowance, volume shrinkage during liquid state, phase transition 4%, solid state 5%. So which volume a riser will cater to? You know, riser caters to particular kind of shrinkage, liquid to liquid and phase change. Solid to solid shrinkage is not catered to by riser. That is the logic. So riser will only take care of As I told, no, this is a pouring temperature, this is a pouring temperature, then there is a freezing temperature, and then there's a room temperature. So what happens is the liquid is first at pouring temperature, then it comes to freezing temperature, and liquid changes to solid, then solid changes to solid. So this one is solid to solid, from freezing temperature to room temperature. Riser does not cater to this. Riser caters to liquid to liquid, liquid to liquid, and liquid to solid. Phase change is liquid to solid. This and this is taken care of by riser. So shrinkage from liquid to liquid. So riser will take care of what? 3% and 4%. So this question I think is already there. This question is already there. You people have done this question in the GATE exam. So riser will take care of this 2 percentages. This you have already done. So 7% is allowance is taken care of by the riser. So this kind of question you can expect in the exam. As I told you, like you need to revise in such a way that simple questions, ticklish question, you are in position, because competition can be high. So these questions, simple and little numerical questions also you have to take care of. And this is another type of question from where he can ask you. Now he will give you one typical casting. You need to design cylindrical riser, and optimum cylindrical riser has height and diameter as same. Optimum cylindrical riser means where you have maximum solidification time. So best shape of riser is spherical, but we cannot make spherical riser because one is production rate will decrease, because making the spherical riser and putting that in the sand and then taking it out, production rate decreases. So why industries do not go for spherical riser? Sir, production rate decreases a lot. Why? Because managing spherical riser takes a lot of time, but they are the best. After spherical riser, second option, good option, is optimum cylindrical riser. Optimum cylindrical riser means height and diameter are same. Now these are attached to the casting, and the casting has a dimension which is given to us. Volumetric shrinkage of the solidification is 3% for steel, and volume of the riser has to be 3% of the shrinkage. So if I give you total volume, of the casting, he says 3% will shrink. So 0.03 of the volume, 0.03 of the volume is 25 into 12.5 into 5. Volume of the casting is given. 0.03, that means 3% of that is the shrinkage, and 3 times the shrinkage is the volume of riser. And what is the shape of riser? Sir, shape of riser is this. This is the diameter, this is the height, which is also equal to diameter. So pi d square by 4 into height, which is d. So this is pi d cube by 4. This is pi d cube by 4. From there, you want to calculate diameter. That's it. So this is a question, very simple question. So 3 times the shrinkage of the casting volume is given. So I think someone has calculated is 5.64. Yes, 5.64 is the answer for this. So 5.64 is the answer for this. So you should know in casting also from where numerical can be asked. To keep doing a lot of practice from casting also, from where numerical can be asked, you people should be aware about that. From where he can ask you question in the casting, that also you should know. So total casting is given, the volume of the casting is given, and 1% of that can be shrinkage, and particular size can give you shape of riser, and the riser is given of particular shape. Okay, in green sand molding process, what is the benefit of uniform ramming? Ramming means hammering करना. Ramming means sand की hammering करना. इससे क्या होता है? Ramming से what happens in the ramming? What happens in the ramming? What do you think is the answer for that? So what is going to happen with the ramming? Are you going to get uniform flow of molten metal into mold cavity, greater dimensional stability, less sand expansion. What are you going to get through ramming? Tell me. Less chance of porosity. Okay, I am sure you know what is a porosity. Uniform ramming leads to greater dimensional stability. Remember this. This is very, very important. Mold strength and dimensional stability. So what happens due to ramming? There are two advantages. एक dimensional stability you get and mold strength increases, right? These two things. Dimensional stability is obtained and then you get the mold strength also. Ramming से strength तो बढ़ेगा. Mold strength will increase because you hammer it, and because of the hammering the sand becomes, you know, quite good, so that becomes strong. So that hammering से एक advantage तो वो होगा, and the second is it makes dimensionally stable. These are two advantages of that, right? So ramming से क्या advantage मिलता है? Dimensional stability you get and mold strength also is obtained. Dimensional stability is very, very important thing, right? Great dimensional stability of the casting. So that is answer is C. Okay, shrinkage allowance on pattern is provided in order to compensate the shrinkage when. Very simple question. We have already discussed this question. Tell me what is the answer to that. We have already answered this question. Tell me what do you think is the answer to this. Shrinkage allowance on pattern is provided in order to compensate for which kind of shrinkage? Which kind of shrinkage do you compensate for? What is the answer? What do you compensate here? Okay, so answer for that is C. Solid shrinkage are compensated by shrinkage allowance. That is the point. Solid shrinkage it is called. Pattern will give you solid shrinkage. So when temperature of the solid phase drops from freezing temperature to room temperature, the other two are taken care of by riser. I told you other two are taken care of by the riser, but this is basically talking about, this is taking care of pattern. Solid shrinkage is taken care of by the pattern. Other two are taken care of by the riser. Right? So let's go for next question. Why do you use investment casting? Why do you use the investment casting? Answer the question. Why do you use investment casting? Mass production, complex pattern, stainless steel part. Yes. Investment casting is used for what? Shapes which are complex, intricate, and cannot be cast by any other method. Stainless steel part, complex pattern in sand. Which one do you want to hit? Investment casting. Yes, answer is complex shapes which are difficult to produce by any other method are possible since pattern here is withdrawn by melting. This is a very, very important part. The pattern here is basically the expandable pattern, that is a wax pattern. Expandable pattern बोलते हैं इसको. Expandable pattern. Expandable and pattern tree is used. So couple of things you remember. There is a pattern tree. There is a full tree made up of wax pattern. And when the molten metal is put in that, the wax will melt and go away. Give the space to the molten metal. And wax can be made of any intricate shape. As you know, the pattern of wax can be made of any intricate shape. And when the molten metal goes there, the wax will be removed and the shape, final shape will be formed. I'll tell you. So expandable pattern means pattern will be expand, right? Very fine details, thin section can be produced by using this. Very close tolerances and better surface finish. Very closed tolerances and better surface finish can be produced in the investment casting. It is also known as precision casting or low wax casting. Precision casting or low wax casting. Wax pattern is used to shape a disposable ceramic mold. Right? It is used to basically get a disposable ceramic mold. I'll tell you the meaning of that. And wax pattern is made in exact shape of the item which you want to cast. The pattern is coated with ceramic material. So ceramic mold is made. Anyhow, I'll show you. But as of now, this is the investment casting. Let me show you how it all goes. See the process. This process is explained. So investment casting is explained like this. First of all, you will inject the wax and make the pattern. Wax के pattern बनेंगे and we make a tree of wax pattern. Lot of wax pattern. Can you see this? Lot of wax pattern, and that is a pattern tree. This is called tree of pattern. So remember, if somebody asks you, where do you get the pattern tree? You will say, sir, pattern tree is made in investment casting. So pattern tree is something like this. You make the wax pattern. Then you lower down that wax pattern in the ceramic slurry. There is a ceramic slurry in which you put the wax pattern. You move the wax pattern in ceramic slurry, and then you get this kind of shell around the wax pattern. You get a shell around the wax pattern. Then what you do, you heat this particular entire thing. When you heat it, then wax will go out. When the wax will go out, only hollow ceramic made shell will be left. Now you got the mold made up of shell. So first you made the pattern of wax, then you lower on the wax in the ceramic slurry, and ceramic is sticking around that wax. Heat it up. Ceramic has very high temperature, melting temperature. Wax will melt and ceramic hollow cavity is formed. And then you put the molten metal in this. When you put the molten metal, then the ceramic can be chipped off, and later on you get the final shape, finished casting. So this is the process in investment casting. All of you are already aware about the investment casting. This is how it goes. So another way to see this entire thing. So maybe you can see the ceramic slurry here. This is a wax pattern tree, and you lower down entire tree. Wax is surrounding around it. Now ceramics is around it. Then you put the molten metal, and then wax will go out, and the final molten metal casting you can obtain it. This is how you get it, right? Okay, so all of you know this formula. Chvorinov, tongue twisting name, this formula. So you know this, what is the value of this formula? So solidification time is volume over surface area square into some kind of mold casting constant. So yeah, so all of you know this is the formula for that. So this formula is very, very important to calculate the solidification time. This formula is important to calculate the solidification time. So solidification time is volume over surface area whole square. Very simple question. Let's go for next. Cold chamber die casting is suitable for which of the following material below? There are two kind of die casting: hot chamber, cold chamber. I want to tell you only simple thing. For which material do you go for hot chamber die casting, and for which material do you go for cold chamber die casting? Number one, ferrous materials के लिए तो ये नहीं होता. Non-ferrous material also can be categorized in two ways. Non-ferrous materials also, some are high molten metal, high melting point, and some are low melting point. Now, hot chamber die casting is for low melting point, and cold chamber die casting is for high melting point materials. Listen carefully. So you have two kind of die casting: hot chamber and cold chamber. Die casting is not for ferrous materials. It is for non-ferrous materials. Now, hot chamber die casting is used for low melting point non-ferrous materials. Cold chamber die casting is used for high non-ferrous melting point materials. So let me tell you now if you see lead, tin, they are low melting point. Brass, zinc, they can be high melting point. So now answer for this is, question was cold chamber die casting is used for, answer is high melting point materials like brass, copper, aluminum, and magnesium. So brass, copper, aluminum, magnesium are high melting point non-ferrous materials. And if I tell you others, lead, tin, and all, they are low temperature. So non-ferrous ko you can divide in two ways. Non-ferrous materials you can further divide in two ways: high melting point and low melting point. High melting point is something which is this: brass, copper, aluminum, and all. They are the high melting point. And low melting point is tin, lead, all these things which we have discussed. So let me give you this: zinc, tin, lead. These are the two categories. So zinc, tin, lead are in hot chamber, and aluminum, brass, magnesium, they are in the cold chamber. Important information. What is the difference between cold chamber and hot chamber? Chamber mein furnace is a different unit. It is not a part of casting unit. Furnace is different. I'll show you the diagram. Right? So if you've noted it down, I go for this diagram. Please see this. So this gooseneck shape is in hot chamber die casting. So this is the furnace. Furnace is a part of casting unit. This is the hot chamber. So low melting point material only can be used here. And shots are given. From ladle you put the molten metal and one shot is given. That is, furnace is separately kept somewhere. Furnace is kept. So high melting point non-ferrous material can be used this by cold chamber die casting. So there's a short chamber here, whereas there's a furnace which is a part of your casting process. Okay, so I'm sure you know what is the short blasting, short pinning process. Short blasting means, short pinning means when you throw the compressed air and these ceramic shots and you throw it on some particular material, right? So sand and oxide layer sticking to casting are removed by which of the following process? Which process is used to remove it? And this is the short blasting. So what is short blasting? It is the post production finishing service, and this helps you basically to remove the sand and oxide layer. Surface quality is improved, and some kind of compressive stresses are also induced. So sand blasting, short blasting, sand may you put it sand and there you put it some kind of ceramic material, so that is a short blasting. Abrasive particles, sand is also abrasive particle, so the methodology is different. Compressed air is used for sand. The purpose is sand quality and to remove the roughness. Okay, this we have already done. So which do you use in the mold to increase the heat extraction capacity of sand mold? Which of the following do you use to increase heat extraction capacity of sand mold? Right? Chaplet chills are made up of the metal, but heat extraction capacity is by the chills. You know the meaning of that. Increase the heat extraction capacity, chills are used. Core is something different. Cope and drag are different. Cope, drag, and cheek, there are three parts. And third part is called cheek. Upper part is cope, lower part is drag, and middle part is called cheek. So there are three things which you should be aware: cope, drag, and cheek. Right? Chaplets we have already discussed. Hollow pipes. Which process will you go for hollow pipes? Which process will you go for hollow pipes? centrifugal casting, investment casting, continuous casting, hot chamber die casting. So GI pipes, which you typically know, centrifugal casting is the application for that. Bigger size hollow symmetrical pipes are made by centrifugal casting, and I tell you, centrifugal casting may there's a rotation given at very high RPM, and normally there are no cores. Normally cores are not used. We'll discuss a question where he's asking core is required, but normally to produce the hollow section you do not make use of any core. Normally core is not required. Axis is rotated, and very high centripetal acceleration is given. Right, so this is a motor which makes it rotate. So this is a centrifugal casting. Gating ratio. What do you understand by gating ratio? Ratio of three areas. Which are those three areas? Gating ratio refers to cross-sectional area. Which three areas? What is that area? Sprue, runner, ingate, or what? Sprue, this is not a sprue, this is sprue, runner, ingate. What three areas do you consider in calculation of gating ratio? Which three areas do you consider in calculation of the gating ratio? Yes, answer for this is B. Sprue, runner, ingate. Sprue area, runner, and ingate. So you understand this is a pouring basin, this is sprue, this is runner, and this is the ingate. So the ratio of these three, why do you design it? I told you, like, you design it for even maintaining the entire system you can keep in the pressurized state to maintain the flow, and also directional solidification. I told you there are three ways in which you can get directional solidification. One is this also. This also is a part of design. I mean, how do you design the area and all? So if you want to have a directional solidification, you can also basically decide the cross section areas. And one is the chills which you provide, that also gives you directional solidification. So that also is directional solidification, right? Gating ratio, this is how it is designed. Which force is acting on core when metal is poured into mold cavity? You already done that, we already discussed that. Which force is acting on the core when metal is poured into mold cavity? Gravity force. He is asking not force acting on the metal, he is asking the force acting on the core. Yeah, you have understood it. This is the buoyancy force. It can be hydrostatic force also. If he gives you choice of hydrostatic force, pressure force, buoyancy force is nothing but hydrostatic pressure force only. Buoyancy force is the result of hydrostatic pressure force only. And core prints are provided for that, so that your core does not get lifted. Core prints are provided, and also chaplets are also provided. Chaplets are also provided. You know, density of the core is less than density of the molten metal. There's a reason hydrostatic pressure force or buoyancy force may lift it forward, may lift it upward, sorry. Ability of the casting material to fill the mold cavity is described by what? What is the answer for this? Keep solving, keep providing me the answers. So what is the ability of casting material to fill the mold cavity? What is the ability of casting material to fill the mold cavity? Yes, that is basically called fluidity. See, flowability and fluidity are two different things. See this thing. Basically, fluidity is the property of fluid, how easily it can flow and fill the mold cavity. Flowability is something different, that is related to the sand. These are the two different things. Flowability is different from fluidity. So don't make the mistake. Flowability is related to sand. Fluidity is related to molten metal. It is related to molten metal. Fluidity and flowability. Fluidity and flowability. So it is the ability of molten metal to flow through the gating system, not getting system, gating system, and fill the cavity. Lower the viscosity, better it is for the fluid to fill the intricate shapes. What factors decide the fluidity? One is its molten temperature. If higher the temperature, it will keep on flowing. So this is called fluidity. Short run is because of low fluidity. Short run is also one of the casting defect. Misrun, which is called misrun, is basically because of low fluidity of the molten metal. That is the reason for this. How do you measure the shrinkage allowance? We have already discussed. How do you calculate the shrinkage allowance? What is the unit to calculate shrinkage allowance? Yes, it is the millimeter per meter, or millimeter per meter. And what about our tapered allowance? Tapered allowance, or tapered allowance can also be calculated in millimeter per meter, but also in degree also. Shrinkage allowance is not calculated in degree, it is calculated in millimeter per meter. Now this is one formula which I want you to remember. This formula has also been asked in many exams. So for a gating system, choke area A is to be calculated using the formula. Choke area, there is a formula which I want you to remember. M is the mass of casting, rho is the density of molten metal, H is effective metal height, C is the efficiency factor, and T is the pouring temperature. Pouring time. How do you calculate the choke area? So how choke area is to be calculated? So choke area, there is a formula, and I want you to remember this formula. So choke area A is M over rho Tc over 2GH. Remember this formula. Dimensionally you can prove it. You can also prove this formula dimensionally, but I want you to remember it because many times this question has been asked. Choke area A is equal to M over rho Tc over 2GH, root of 2GH. So what is M? First you write this formula, and then again I show you what these parameters are. A is equal to M over rho Tc, root of 2GH. So what is A? A, I told you, is the choke area. M is the mass of casting, rho density of molten metal. H is effective metal height. C is the efficiency factor. T is the pouring time. T is the pouring time. So what is this? A, choke area is this. Which of the following is not the casting defect? Which of the following is not the casting defect? Hot ears, yes. Run out, yes. Blow holes, yes. Stop off नहीं है. Stop off is not the casting defect. See, casting में से एक question casting defect का you can expect. You can surely expect a question from casting defects. Hot ears, hot cracking is also the same name, and that is because of, we just discussed, casting. As the casting start getting solidified, hot ears is one of the defects which we can see. Run out, misrun, or run out, because of faulty flask. Run out is caused when molten metal leaks out. That is run out, actually caused by faulty flask or mold. Blowhole is a gas which is entrapped. So this, what are the various defects that should be very clear, and what are the reasons for that? These are some defects, and you already know the reasons. Blowhole, pinhole, they are because of the porosity issues. Slag inclusion, wash and cut, shrinkage cavity, hot tears, drop, swell, metal penetrations, cold shut, shift or mismatch. So these are some of the defects, names of the casting, but he will be asking you the reason of these casting defects. So some casting defects you should be aware. Which defect is because of gas inclusion? The defects because of poor strength of sand, the defects because of low fluidity, defects because of low flowability. So different defects and the causes. One of the very important question can be asked from here. Which of the following process, technique, manufacturing technique, production technique does not produce the continuous product? So all these produce the continuous product except one. Can you identify which does not produce the continuous product? Which of the following techniques does not produce the continuous product? Yes, injection molding. Okay, injection molding does it. Okay, what is calendaring process? What is pultrusion process? Okay, I think all these other are producing. Extrusion, you know, calendaring, you know. So let me explain you. This is the calendaring process. The two things which you have not understood is calendaring and pultrusion process. Continuous molding process, reinforcing fibers are saturated with liquid polymer resin and then carefully formed and pulled through heated die is called pultrusion process. And calendaring process diagram, you can see that is a calendaring process. Series of pressure roller used to finish or smooth a sheet of material like plastic, paper or anything. So that is calendaring process. Calendaring process is also continuous process. Pultrusion process is also continuous process. So pultrusion process, calendaring process, they are the continuous processes. Pultrusion, calendaring processes, they are continuous processes. Injection molding is not a continuous process, as you are aware. Now, from this, shrinkage allowance, say in casting, you can expect a question in casting from shrinkage allowance. If a cube of 100 millimeter dimension is to be made from aluminium, there is a shrinkage allowance given per meter 10 millimeter. Per meter, there is a 10 millimeter of shrinkage allowance. What will be dimension of wooden pattern? So we want to make 100 millimeter dimension. So tell me one thing, should the pattern be larger size or smaller size? First you answer that question. The pattern should be larger size or smaller size? And he is asking you wooden pattern ka dimension. Final dimension is given to us. And shrinkage is also given to you. That is 10 millimeter per meter. So what should be the size in millimeter? What will be size in millimeter? 1000 millimeter में shrinkage is 10 millimeter. So 100 millimeter में it is 1 millimeter. So 100 millimeter में there will be shrinkage of 1 millimeter. 1000 millimeter में 1 meter is 1000 millimeter. So 1000 millimeter में shrinkage is 10. So 100 millimeter में size is 100 millimeter. So cube is there. So all the three sides shrinkage will be same. So there is a cube. Each size is 100, 100, 100, right? And 1 millimeter will be shrinkage. So obviously we have to make a pattern the size 1 more than this, 101 into 101 into 101. That is the thing which we have to make. There can be positive shrinkage, there can be negative shrinkage. You have to be very clear which shrinkage you are talking about, positive or negative. Right? Okay, this is also good question. A casting of this size solidifies in 20 minutes. In the same condition, what will be the solidification time for casting of size this? So first size he has given you and is asking you what will be the, he is giving you the solidification time of 20 minutes. So that means this question is related to solidification time. This question is related to solidification time. A casting of size 100 into 100 into 100 millimeter cube solidifies in 20 minutes. So how much time will be taken to solidify casting of size 100 into 100 into 50? So 100 into 100 into 100 in 20 minutes, how it will be solidified? So it is a very simple, I mean you have to use one formula, solidification time formula. You have to use this formula of solidification time. K is the solidification constant or this thing. This is the volume, this is the area. So now in first case, you know, volume per unit area. This is the cube of, you know, 6 face. So what is the surface area? 6 into a square. Volume a cube. So solidification time is given, volume is given, area is given. From there, solidification constant can be calculated. This is K is solidification constant. You know this formula, right? We just use this formula. This K is solidification constant. If the material is same, solidification constant is going to remain same. So just K value I am to use. In this case also V over A I got it. So T1 is equal to K into V over A whole square. T2 is equal to K into V over A whole square. Now this K will get cancelled out if you take the ratio of 2. I want to calculate T2. T1 is 20 minutes. So V over A whole square in second case, V over A square in the first case. In the first case is a cube, in the second case it is not cube. So 100 into 100 into 50 and then you calculate the area. So very simple question, not a difficult question. It is a simple question. And then you can calculate. So 11 minutes will come answer to this. Answer will be somewhere 11 minute, 11.3 minute. Right? Then we go to next. In sand casting, when it is not possible to get very fine details on surface, then some modifications are done in a pattern, which is called what? See, this is an interesting question actually. Pattern allowance, shrinkage allowance, machine allowance, core print. What is the answer? I mean, you can solve this question through elimination. You can solve this question through elimination. When you do not get very fine details on surface, then what do you do? What do you do? When you do not get the details, very fine details on surface, then what you do? That is the question. What do you do in that situation? That is basically eliminated then. Answer is elimination. When it is not possible to get very fine details on surface, then some modification which is done is called elimination of details. So as I told you, you could have eliminated the answers and from there you could have obtained the answer through elimination. You could have eliminated it and obtained the answer for that. You could have eliminated and obtained the answer. Right? This is called elimination of the details. This we have already done. What is the answer to this? You've already answered this. Ability of the molding material to withstand high temperature of molten metal so that it does not cause fusion. You have already done this. What is that property called? And these all are properties. This is called refractoriness. Why 1650 degrees centigrade? Because you know iron or steel, they are in this range. So iron का melting temperature is in this range 1650 डिग्री सेंटीग्रेड से आपके पास वो टेम्परेचर चाहिए रिफ्रैक्टरीनेस का. So that sand should have this much of temperature, right? Ability of the molding metal to withstand high temperature. Let's go next. Binder. Which one do you use as binder? Yes. So in core sand, which one do you use as binder? Which one do you use as a binder? Fire clay. Okay. ओके बाइंडर में हम यूज करते हैं लिनसीड ऑयल. दिस ऑयल इज यूज्ड एज बाइंडर. There's a core sand has the sand grain organic binder, and then you bake it and then you get the strength of this, right? This is the, so linseed oil is used as a binder. Just remember this information. Okay, do you know what is slag? How do you trap a slag in casting? In sand molding, how do you trap a slag? Slag is something which you want to remove. How do you trap? What are the options? Strainer, you must have heard. Pouring basin is also one of the ways. Pouring basin में दो benefit होते हैं. एक, slag को you trap, another turbulence also you prevent. Runner extension, yes, that is also done. Whirl gate is also one. I mean, bottom gate and top gate. Bottom and top gate are not for slag. No, bottom gate is not for slag. Do you think bottom gate is used to trap the slag? Top gate, bottom gate, they are two different kind of gates, right? Yeah, so bottom gate is not the answer, but try to remember the other points. Pouring basin is there, strain is there, runner extension is there, whirl gate is also there. So bottom gate is not one of the ways. Bottom gate is actually not one of the ways. Bottom gate is not one of the ways to trap the slag. You know that bottom gate तो आपने किया है. You have already done the bottom gate. It is not one of the ways. Cylindrical blocks in internal combustion engine. Typical application है इसका. Cylindrical blocks, the cylinder of internal combustion engine cast iron का बना होता है. The cylinder of internal combustion engine is made up of cast iron, and that is made through casting. So remember this always. The cylinder in internal combustion engine is made up of cast iron, and the typical application of casting. Casting का application है. This is the typical application of casting. Why do you use this of cast iron? Because cast iron has very good resilience. The resilience of cast iron is very good, and the cylinder block is subjected to high pressure, fuel pressure, and hence it should be in position to take that particular energy. So the pressure force energy should be taken by this. Sand casting is used for that. Right? So what is the disadvantage of die casting process? What do you think? What do you think is the disadvantage of die casting process? What is the disadvantage of die casting process? Just hit one of the answers. Die casting process. Can you make a very large sections using die casting? Surface finish is good, no doubt. Cost also, once you go for mass production, cost is also less. High production rate are possible. High production rate can also be there. But which of the following is disadvantage? Which you cannot make? What is the disadvantage of that? Disadvantage of die casting process are, number one, all metal and alloy cannot be cast. I mean, iron, ferrous casting cannot be done of the ferrous materials. Machine, die, other equipment is high, but mass production के लिए it can become, but otherwise it is high. Heavy casting cannot be cast. Heavy casting cannot be made. because very large size die cannot be made. Surface quality is good, but not all materials can be cast. It's costly thing. Die is very costly thing. Large size die will be very costly affair. You cannot make that big size of die. The cost will be very high. So disadvantage of die casting processes are this. You should know these are the disadvantages of die casting process. Centrifugal casting do not have cores. Centrifugal castings do not have cores. But if he asks you ever that what are the cores used, they are nothing but green sand only, if this is used. But normally, as I told you, they do not have cores. So centrifugal casting में core नहीं होता, but if at all you have to use, then special type of sand core is used in centrifugal casting. No requirement of core for making concentric hole. But if sometime he asks you, then you will say special type of sand casting. Special type of sand core can be made. Okay, I think we have come quite above. Let me go down. Okay, I think this is somewhere we were at this point. Yeah, this we have done. Centrifugal casting is used for what? Please answer this. Why do we use true centrifugal casting? True centrifugal casting is centrifugal casting only. Why do we use true centrifugal casting process? Why true centrifugal casting process is used? True centrifugal casting, why is this used? What is the answer for that? Okay, symmetrical about an axis. A is the answer for that. Making the hollow pipes and tubes which are symmetrical with concentric hole, and very high rotational speed is required. So very high rotational speed is required in this particular true centrifugal casting process. And if it is not true centrifugal casting process, there is centrifuge kind of things also. So what is sprue? Which is the answer? Sprue is what? Sprue is what? Passage through which molten metal is introduced into the mold. Very simple. So I think this is very simple. All of you can answer this. So what is sprue? This is the answer for that. So what is the main purpose of the sprue? And how the sprue is designed? Sprue is designed in such a way that there is a no aspiration effect. There is no aspiration effect. Getting design ka, this is important part. So everywhere pressure is uniform. It is designed in such a way that everywhere pressure is uniform. So sprue is designed for uniform pressure everywhere, and there should not be any aspiration or suction of the gases. Where is the riser located? Where do you locate the riser? Riser is generally located. Where do you locate the riser? Yes. Parting line, uppermost section of casting, deepest most section of the mold, opposite to pouring end. Where do you think it should be located? Riser. Top riser, there is a side riser, uppermost section of the casting. Can you see this? There is a side riser also. Top riser, side riser. Normally top riser. Sprue, top riser, molten metal. So riser is normally located here, down sprue, and then there's a runner, there's a mold cavity, cope, drag. So you can see where the riser is put, and then there's a core also you kept in this particular diagram. So riser is normally top riser and side riser. Question can be, what is the benefit of side riser, what is the benefit of top riser? Right? So riser is uppermost section. Why pouring basin is provided? What is the advantage of pouring basin? What do you think is the advantage of pouring basin? Is provided in the sand mold for what? Why do you provide pouring basin in the sand mold? What is the answer for that? To increase the fluidity, improve the property of sand, maintain high temperature. Yes, there are two advantages of pouring basin. One, it maintains the constant head. It maintains the constant head. It prevents the slags. It basically separates the slag. Three, it prevents the turbulence in the liquid metal. So let's say three advantage of pouring basin. The moment you maintain pouring basin, constant head of the liquid is maintained. So the flow at particular velocity can go. Second, slag separation. Third, turbulence can be controlled. This is the advantage. Turbulence can also be controlled. These are some of the advantages of pouring basin. Slag separation can be done, constant head can be maintained, and this turbulence can also be avoided of the molten metal. So slag, dross, these things you should know. What is the meaning of it? These are the three advantages of having pouring basin. Die casting mold are made up of what? In the die casting process, the mold are made up of what? What do you think are mold made up of? Okay, all of you know the answer. They are made up of metal. Advantage of die casting is very good quality surface, dimensional, tolerance is obtained. So heat can be extracted. Water cooling channel can be used in this. What is Tuyerer? Tuyerer. Cupola furnace. So cupola furnace is the first furnace, So what is Tuyerer in cupola furnace? Any idea about this? Okay. So cupola furnace and type of furnace I will discuss. Supply of air for combustion in cupola with the help of blower. Tuerers are basically to supply the air for combustion in cupola furnace. I think this question was asked in one of the exams related to this only. Which of the following is not part of gating system? Any idea? Which of the following is not part of gating system? Sprue, vent, pouring basin, gate, and riser. Which one is not part of gating system? What is vent? Do you know what is vent? Any idea what is vent? So vent is not part of gating system. So vent is not the part of gating system. You know that. Ornament. Which casting process? Tell me which casting process for ornament? Centrifugal, die casting, continuous casting, what? Which casting do you use? So this pressed casting is also called slush casting. Slush casting is a typical example for which ornaments can be made. You know what is slush casting? In the molten metal, in the cavity, mold cavity, you pour the molten metal, then you remove it after some time, and a very small thin, this particular layer of molten metal sticks to the mold cavity, and that you can take out, and this is the very thin section. Slush casting basically. So slush casting is a typical example of that. Permanent mold you have. Molten metal is does not completely solidify. So see this. Desired thickness is obtained desired thickness is obtained because molten metal is not allowed to completely solidify. You don't let it to get totally solidify. Desired thickness is obtained by removing the molten metal. So ornament, typical example of ornament is slush casting. Sand is packed on pit mold with. So there is a one particular device here which is used to handle the sand. There is a device here which is typically used to handle the sand. Can you tell me which device is that? Typically used to handle the sand. That is the sand slingers. Sand is basically handled using sand slingers. Sand slinger. This is how you do it. There's a name of this device. It is packed on pit mold with sand slingers. Just remember the names, they are important. Die cast parts are used when which of the following is true? Die cast. Why do you go for die casting? We just discussed when do you go for die casting. So when do you go for die casting? What do you think? You go for die casting for particular purpose, and that purpose is low melting point material. Ferrously, you don't go for die casting. You don't go for die casting in ferrous materials. You go for small size die casting. And you go for when there is a mass production. Large scale means mass production. Small size means you cannot have very big size of die casting. And melting point of molten metal which you are using should not be very high molten metal. I mean, the melting point should not be high. That is the reason die casting you will go for it. In die casting, which of the following is true? Any metal can be cast. No. Ferrous cannot be cast. Any size of metal casting can be prepared. No. Large size we don't do. Cost of die is generally insignificant. Actually, it is significant. High production rate as possible. Yes, it is designed for high production rate. Die casting is designed for high production rate. So answer is D. High production rate is possible. You go for high production rate. What is the main advantage of investment casting? What do you think is the main advantage of investment casting? Raw material required are cheap. No special tooling is required. No sophisticated technology involved. Can be conveniently adopted for heavy casting. What do you think is the advantage of investment casting? Just give the answer. What do you think is the advantage? Okay. Heavy castings. Can it be used for heavy casting? Yes. Small, heavy and large casting. Investment casting can be used for small. It is very surface quality is very good, and nowhere we get to know that it cannot be used for large size. Yes, it can be used for heavy size. So I think we will be completing it in next 10 minutes. So in 2 hours we will be completing this all the topics which we are covering. So they are good questions for your exam. Molten metal is not introduced directly into the mold cavity, as it will lead to what? Crack, breakage, erosion, corrosion. Very simple question. Top gate, bottom gate. I don't go for top gate. You know what is top gate? There is a molten metal and this is the cavity. Suppose the gate is like this. This is called top gate. Top gate mein filling will be very fast. So filling will be very fast, But top gate mein there's another trouble. Filling will be very fast, but turbulence will be very high. Erosion will be very high. So you don't go for top gate or this, because it will lead to lot of erosion. Erosion will be very high. Erosion will be very high. This we have done. Shrinkage allowance to the pattern. We have done this. I think this question we have already done. Let's go for this. Which is not a casting defect? Mishran, lift and shift, cope and drag, sponginess. Cope and drag. You know what is cope and drag? What is cope and drag? Cope and drag. Cope and drag is not the casting defect. What is cope and drag? We just discussed, if there's a casting made up of mold, casting is three part: cope, drag, cheek. There are three component: cope, drag, cheek. Three parts of mold cavity: cope, drag, cheek. Casting defects are blowhole, air inclusion, pinhole, cut and washes, fusion, drop, all these things. Right? So cope and drag are not casting defects. Now this question, I don't know, many times this question has been asked, that what will be the accuracy of shell molding? What is the accuracy of shell molding? Dimensional accuracy it is asking about. That per meter, how much will be the dimensional accuracy? That is the question. Any guess? What is the dimensional accuracy of this shell molding? Any guess? Just remember it. I don't know. The question has been asked many times. So remember this. 0.003 to 0.005 millimeter per millimeter. So that is the accuracy of shell molding is this. Okay. Permanent mold casting. Which of the following are the features of permanent mold casting? Permanent mold casting. Which of the following are feature? Permanent mold casting. Just listen, read to this and tell me what do you think is the answer. Permanent mold produces sound dense casting with superior mechanical properties, quite uniform in shape and have high degree of dimensional accuracy than casting produced in sand. Permanent molds is also capable of producing consistent quality of finish. Cost of tooling is usually higher. Yes, process is generally limited to the production of small casting of simple exterior design. This is also correct. Just read it and tell me what do you think is the answer. What do you think is the answer? Dense casting with good mechanical properties. Uniform in shape, high degree of dimensional accuracy. That is also there. Mechanical properties are good. Dimensional accuracy is also good. Quality of finish is also good. Cost of tooling is high. Okay, let's see what is the answer for this. So all are correct. All are correct. So permanent mold casting, these are the advantages. Mechanical properties are good, quality is good. You know, we can produce small size only, not very big, because permanent mold is very costly. So since permanent mold is very costly, we cannot produce very large size. Okay, now answer this question. To minimize turbulence, to avoid tapping gases into mold, why do we go for gating system? Why do you design gating system? So 1, 2, 3, 4, 5, all these options, tell me which one is correct. Why do we go for gating system? To minimize turbulence, enough metal into mold cavity before metal gets solidified, avoid shrinkage, temperature gradient in solidified casting. Okay, trapping non-metallic inclusion. Does not incorporate a system for trapping non-metallic inclusion. I don't think it can be there. Non-metallic also is to be done. What do you think is the answer? Gating design. So you think D is the answer. Okay. No, that is for earlier or this one? Monali is giving the answer for this one or what? So which are the goal of gating system? Why do we make the gating system? That is a question. Why do we design the gating system? Does not incorporate system for trapping non-metallic inclusion. Non-metallic inclusion के लिए we don't make the system. C is what? Okay, that is what I was telling you. This 5 is wrong. Fifth choice is wrong. Yes, fifth choice is wrong. So these are the goals of gating system. The objective to design gating system are given in this particular question. So he has explained you the objective of gating system. Okay, he's given you gray cast iron block. Shrinkage allowance is 1%. What will be the ratio of volume of pattern to that of casting? Gray cast iron. There is something special about gray cast iron. He's given you the iron block and it is to be cast in the sand mold. Gray cast iron has something special. The shrinkage you need to see. Gray cast iron में क्या होता है? After solidification, its size increases or decreases. That is what you need to see. So we need to make the pattern of small size or large size. Though this is given to us. Now, in many books, there's a 1% means 200 by 1. So this is the kind of size of. Now, in many books, it is said that gray cast iron will, if we solidify it, after the solidification, the size will increase because the gray cast iron expands. But in some books, it is the reverse. I've taken it the second option. So pattern size is bigger than casting because we assume it shrinks. But I don't know. I mean, in many books where it is given that it shrinks, not expands. And in the gate also this question has been asked where they have taken this particular size only. This particular only they have taken. What is shift? Shift casting defect. What do you understand by the casting defect? Which is shift? Shift casting defect is what? When do you see the shift? Because of mismatch in top and bottom part of casting or what? There is a mismatch between top and bottom casting. So mismatch means then cope and drag may the things are not there. Like this is one and this is called mismatch. And maybe it is because of cope and drag may there is a mismatch. So this kind of defect. Mismatch is because of that. Property of sand due to which the sand grain stick together is called what? Property of the sand due to which sand grains stick together is called what? Sand grain stick together is called what? Okay, the answer is it is called cohesiveness. Cohesiveness. Yeah, answer is cohesiveness. Right? Let's go for next. Now, this kind of questions they are taken from engineering services, but good question. Thicker section of casting take longer to solidify than thinner section. Correct or not? Thicker section of casting carry residual stresses. Thicker sections carry residual stresses. Thicker sections take more time to solidify than thinner section. Which one do you think is correct? Both the statements are correct or only one statement is correct? Thicker section of casting take longer to solidify than thinner section. Thicker section of casting carry residual stresses. Okay, thicker section take longer time for solidification because they have high volume to area ratio and they have more residual stresses due to high differential cooling rate. So both the statements are correct. Right? So I think the statements you should see, both the statements are correct. So this part may be useful to us, thicker section and thinner section. Thicker section also develop more residual stresses due to high differential cooling rate. Sand with grain of uniform round shape is preferred for preparing the mold. If grain are large and regular, air venting property of mold would be better. So grain size of the sand, that is also one of the criteria. How the grain size of the sand decides the venting property. How is that decided? And this is the answer. Uniform grain size do not provide good strength. Remember that. If the grains, all the grains which you are using are of same size, then strength will not be obtained. That is number one, you should remember. Sand is basically in different shapes, sizes. If high grain size is there, then porosity property will be high. Porosity property is high if the size is more. So grain size is also one of the very important parameter in deciding the properties of the grains. What is hot tear? What do you think is the hot tear? You know, this is a casting defect. So hot tear is nothing but hot cracking. Hot tear is hot cracking. It is when metal is weak, when it is hot, and residual stresses can cause the casting to fail. So that is called hot tear, right? So I think now we ended up our lecture here only. So I'm sure this video will be available on YouTube. So please raise all these questions of casting. I'll come and we'll go for some more questions on, we'll go for some more lectures on live lectures on production engineering, so that you people are in position to solve a lot of questions of production engineering and this expected question for your exam. I hope you understood whatever we discussed. So go through this, and this document you can take, this PPT you can take, and you can revise this. You need not to write this, right? Thanks a lot, Monali, and thanks a lot to all of you who joined me for this lectures. Thank you.